In this activity, we're making 3D shapes that represent the unit cell, or the basic repeating unit that makes up a larger crystal. To make the unit cells, carefully cut out the mesh. Be sure to include the tabs. Use a toothpick to poke holes in each face of the shape through the circles indicated. Put it aside, but not too far away. We'll need it again in a minute. Then fold outward along all the solid lines so that the printed design will end up on the outside of the 3D shape. Now use tape or glue on the tabs to secure the design. Once your unit cells are built, you can insert the toothpick through the holes you made in the faces. If I poke it through the Y circles, the toothpick represents the Y-axis. Looking down the Y-axis, I can rotate the cube counterclockwise or clockwise. If it's rotated 90 degrees, the shape of the cube is still a square. This is an example of rotational symmetry. When I turn the cube by a specific amount, it ends up looking the same from my perspective. This face of the cube also has a couple mirror symmetries. If I imagine flipping it across this axis, which represents the x-axis, then the shape would be totally the same. It's also true if I flipped it across this axis, the z-axis. That's because this face has mirror symmetry across the x and z axes. These symmetries will become important when we start assembling our unit cells into larger crystal structures.